You can't become Isaac Newton, but you can steal his secret. It's not about being born a genius. It's about a specific mental habit he practiced every single day, a habit that unlocked the laws of our universe. And it's something anyone can learn. In the next few minutes, we're going to unlock his private notebooks, decode the strange symbols he hid from the world, and uncover the one question he asked himself that led to discovering gravity, calculus, and the laws of motion. This wasn't just science. It was a deeply personal, obsessive quest that nearly drove him mad and changed the world forever. When you think of Isaac Newton, what's the first image that comes to mind? For most of us, it's a man sitting under a tree. An apple falls, bonks him on the head, and in a flash of brilliant insight, gravity is born. It's a great story. Simple, clean, and satisfying. It makes genius feel like a lightning strike, a moment of pure, unearned inspiration. The problem is, it's almost entirely wrong. The real story is far messier, far stranger, and infinitely more interesting. The real secret to Newton's genius wasn't a gift from the heavens. It was a tool he forged himself, a way of thinking so intense, so focused, that he could hold the entire universe in his mind until it gave up its secrets. This isn't just a history lesson. This is about deconstructing the process of a mind that rewired human reality. And it all starts not with an apple, but with a lonely, angry child who felt abandoned by the world. Isaac Newton was born on Christmas Day in 1642, the same year Galileo Galilei died. The symbolism is almost too perfect. He was born into a world of turmoil. England was in the middle of a civil war. He was born premature, and so tiny that no one expected him to survive the day. His father, a farmer also named Isaac, had died 3 months before he was even born. Then, when he was just 3 years old, his mother remarried a wealthy clergyman and left. She moved to a nearby village and left young Isaac behind to be raised by his grandmother. Imagine that. A small, frail boy with no father and a mother who, in his eyes, had abandoned him. This sense of loss and abandonment would shape his entire personality. He grew up to be secretive, suspicious, quick to anger, and pathologically unable to handle criticism. In one of his notebooks from when he was a teenager, he made a list of all the sins he had committed. Among them was, threatening my father and mother Smith to burn them and the house over them. This was not a happy, well-adjusted child. He was an outsider from day one. He found little comfort in other people. So he built a world inside his own mind. He filled notebooks with drawings, diagrams of windmills and water clocks, and intricate notes. He wasn't just doodling, he was analyzing. He was taking the world apart to see how it worked. So if he wasn't this divinely inspired figure, where did his incredible power of mind come from? It started not in a fancy university lab, but alone, in a locked room with a notebook and a question. At the age of 19, he went to Trinity College, Cambridge. He was what was known as a sizar, a student who worked as a servant to wealthier students to pay for his tuition. Again, he was an outsider. While his classmates were studying the officially sanctioned curriculum of Aristotle, Newton was devouring the forbidden works of the new scientific revolution. He read Descartes, who saw the universe as a giant machine. He read Kepler, who had figured out the mathematical laws of planetary motion. He was teaching himself, building his own curriculum in the shadows. He kept a special notebook during this time. He titled it Questiones Quaedam Philosophicae, or Certain Philosophical Questions. This notebook is one of the most important documents in the history of science. It's here we find the first glimmer of his real secret. He didn't just write down facts. He organized his thinking around questions, huge questions. Under headings like of time and eternity, of motion, of colors, he listed everything he didn't understand. He was creating a map of his own ignorance, and this is the first key to his mind. He was obsessed with what he didn't know, not what he did. Then, in 1665, disaster struck. The Great Plague swept through England. London was devastated. Cambridge University shut down, sending all its students home. For Newton, home was a small farm called Woolsthorpe Manor. For the next 18 months, as the world outside was gripped by fear and death, the 23-year-old Isaac Newton was alone. He had no professors, no assignments, no distractions. He had only his books, his notebooks, and his own thoughts. Historians now call this period his Annus Mirabilis, his year of miracles, because in that period of intense, forced isolation, he laid the foundations for the work that would define his entire life and our modern world. He developed the fundamental principles of calculus, which he called his method of fluxions. He performed his famous experiments with prisms, proving that white light was not pure, but was actually a mixture of all the colors of the rainbow. And he began to think, really think, about the force that governed the heavens. But how? How did he make these incredible leaps in such a short time? It wasn't a series of happy accidents. It was a conscious, deliberate process, a mental state he could enter at will. He called it contemplation. Years later, when asked how he made his discoveries, he said, "I keep the subject constantly before me and wait till the first dawnings open slowly, by little and little, into a full and clear light." His personal assistant later wrote that Newton would often forget to eat when he was deep in thought. He would get up from bed, sit on the edge for hours, fully absorbed by a problem in his mind, and then go back to sleep having forgotten to get dressed. His power was his concentration. He could stare at a problem longer and harder than anyone else. He would turn it over and over, looking at it from every possible angle, not resting until he had cracked it open. The answer is in his notebooks, and they reveal the second part of his secret, a method of relentless, systematic questioning. Let's go back to his Questiones notebook. It was an organized assault on ignorance. He created 45 headings under which he would categorize the world. Let's take the problem of light and color. He bought a prism at a local fair and took it back to his room. He cut a tiny hole in his window shutter, creating a single small beam of sunlight. When he passed this beam through the prism, he saw the familiar rainbow of colors projected onto the far wall, the spectrum. But he didn't stop there. He started asking more questions. What if he tried to split one of those colors? He took a second prism and tried to pass just the red part of the spectrum through it. What happened? The red light came out the other side, still red. This led him to a revolutionary idea. What if white light wasn't pure at all? What if it was a mixture of all these fundamental colors combined? He devised a brilliant experiment to test it. He used a lens to take the full spectrum of colors coming from the first prism and refocus them all back into a single spot. And when he did, a beam of pure white light emerged. This is the Newtonian method in action. It's not a flash of genius. It's a grueling step-by-step interrogation of nature. Step 1. Confront a piece of accepted wisdom. Step 2. Ask a relentless series of simple, practical questions. Step 3. Devise a simple physical experiment to answer each question. Step 4. Patiently observe the results. Step 5. Build a new theory based only on what the evidence tells you. He applied this same relentless questioning to everything. He would break down any problem, no matter how vast, into the smallest possible pieces and attack each one individually. But how did he apply it to the biggest question of all? What keeps the moon from flying away into space? This brings us to the famous apple. The problem of gravity was the ultimate challenge. An apple falling to the ground and the moon circling the Earth were considered two totally separate phenomena. The challenge, the problem Newton faced, was to connect them. It required a leap of imagination so vast it's hard for us to even appreciate today. He had to imagine that the same messy, mundane force that pulls an apple to the dirt could also be the force that holds the majestic moon in its orbit. The story of the apple, as Newton later told it, wasn't about it hitting him on the head. He was in the garden at Woolsthorpe, and he saw an apple fall, and he began to wonder. The apple falls. It is pulled toward the center of the earth. The power of gravity must extend at least to the top of the apple tree. He then asked one of his classic, simple questions. How far does that force extend? Does it reach the top of the highest mountain? Surely it must. Well, if it reaches the top of a mountain, does it keep going? Does it reach all the way to the moon? This was the imaginative leap. He started to wonder if the moon wasn't so different from the apple. Maybe the moon is also constantly falling toward the earth. The reason it doesn't crash into us, he thought, is because it's also moving sideways at a very high speed. Imagine firing a cannonball from a very tall mountain. Fire it slowly, and it arcs down and hits the ground. Fire it faster, and it goes farther before it hits the ground. Now, he wondered, what if you could fire it so fast that as it falls, the Earth's surface curves away from it at the exact same rate? The cannonball would keep falling forever but never get any closer to the ground. It would be in orbit. Maybe that's what the moon is doing. It's a projectile, constantly falling but always missing. It was a beautiful idea. But an idea, for Newton, was worthless without proof. He needed to find the math. He reasoned that this force of gravity must get weaker as you get farther away from the Earth. But by how much? He came up with a hypothesis, possibly by looking at the work of Kepler on planets. He proposed what we now call the inverse square law. It's a simple but profound idea. The strength of the gravitational force is inversely proportional to the square of the distance between two objects. In simpler terms, if you double the distance, the force doesn't get 2 times weaker, it gets 4 times weaker, or 2 squared. If you triple the distance, it gets 9 times weaker, or 3 squared. He had found the mathematical language to describe how gravity weakens over vast distances. He had the theory. Now he just had to test it. He knew the moon was about 60 times farther from the center of the Earth than the apple on the ground was. So, according to his inverse square law, the gravitational force at the moon should be 60 squared, or 600 times weaker. He needed to know how fast an apple accelerates as it falls, and he needed to know how fast the moon falls or deviates from a straight line in its orbit. The problem was, to do the math right, he needed accurate data for the radius of the Earth and the distance to the moon. And in the 1660s, the numbers he had were slightly off. When he crunched the numbers, his answer was close, agonizingly close. But it wasn't perfect. For a mind like Newton's, close was the same as wrong. He couldn't prove his theory to the level of precision he demanded. And so what did he do with this earth-shattering insight? This idea that would form the bedrock of physics for the next 200 years? He put it in a drawer. He just set it aside. For almost 20 years. This is maybe the most shocking and important part of his secret. It's not just about intense contemplation and relentless questioning. It's also about superhuman patience. He was willing to wait. He knew the idea was right, but the data was wrong or his math wasn't quite there yet. He turned his attention to other things. He delved deep into alchemy, the mystical forerunner of chemistry, filling his lab with furnaces and chemicals, searching for the philosopher's stone. He spent years on radical religious studies, trying to prove his secret belief that the doctrine of the Trinity was a fraud. To an outsider, it looked like he had abandoned physics. He became a professor at Cambridge, but was known for giving lectures to an empty room because no one could understand what he was talking about. So he had this world-changing idea and just put it in a drawer for 2 decades? What on earth could possibly make him pick it up again? The answer is a visit from another brilliant scientist, a man who was everything Newton was not, charming, sociable, and a great communicator. His name was Edmund Halley. In August of 1684, Halley travelled to Cambridge to visit the strange, solitary Professor Newton. Halley and his colleagues in London, like Robert Hooke and Christopher Wren, were consumed by the same problem that had vexed Newton 20 years earlier. They all suspected that an inverse square law of gravity was the key to explaining the elliptical orbits of the planets that Kepler had described. but none of them could prove it mathematically. So Halley asks Newton a direct question. He says, "Dr. Newton, what path would a planet take if it were pulled towards the sun by a force that followed the inverse square law?" Newton's answer was immediate and casual. An ellipse. Halley was stunned. This was the answer he and his friends had been searching for years. He excitedly asked Newton how he knew. Newton replied, "Why, I have calculated it." This is the climax of the story. The moment everything changes, Halley, breathless, asks to see the calculations. Newton starts rummaging through his famously chaotic piles of paper. He looks, and he looks, and he can't find it. The most important piece of paper in modern science was lost somewhere in his messy office. It's a moment that is both terrifying and deeply human. Newton, embarrassed, promised to redo the calculations and send them to Halley in London. A few months later, a small manuscript arrived for Halley. It was titled De Motu Corporum in Gyrum, or On the Motion of Bodies in an Orbit. It was 9 pages long. But in those 9 pages, Newton not only proved that an inverse square law leads to elliptical orbits, but he laid out his fundamental laws of motion. Halley was blown away. He knew instantly that this was something much bigger than just an answer to his question. This was a complete new system of physics. He rushed back to Cambridge and begged Newton to publish his work properly, for the whole world to see. Halley even offered to pay for the printing costs out of his own pocket, because the Royal Society, England's main scientific body, was broke after publishing a lavish book called The History of Fishes. Spurred on by Halley's encouragement, Newton did something extraordinary. The floodgates opened. For the next 18 months, he worked with a focus and intensity that even for him was legendary. He cut himself off from the world. He barely ate or slept. His whole being was consumed by one task, writing the book that would explain the entire system of the world. He was not just writing down what he already knew. He was inventing entire new fields of mathematics and physics as he went along, building a logical structure of breathtaking power and elegance, all starting from a few simple axioms. In 1687 the work was published. It was called Philosophia Naturalis Principia Mathematica, or The Mathematical Principles of Natural Philosophy. We know it today simply as the Principia. It is, without exaggeration, one of the most important books ever written. It gave us the 3 laws of motion. It gave us the law of universal gravitation, showing that the same force that makes an apple fall also holds the planets in their orbits. He explained the tides, the paths of comets, the wobble of the Earth's axis. He created a unified mathematical system that could describe the motion of everything from a falling stone to a distant galaxy. The universe was no longer a mysterious divine place. It was a rational, predictable machine that operated according to universal, knowable laws. And Isaac Newton was the man who had read the instruction manual. So what is the secret of being a genius like Isaac Newton? After all this, after diving into his life and his work, what can we take away? It's not about being born with a magical brain. It's not about a lucky apple. It's a process. It's a way of being. We can break it down into 3 key parts. First, there is the power of uninterrupted, obsessive contemplation. Newton's ability to hold a single problem in his mind for inhuman lengths of time was his primary weapon. In our modern world of constant distraction, notifications, and endless scrolling, this skill of deep, prolonged focus is rarer and more valuable than ever. He practiced a kind of mental solitude that allowed the first dawnings of an idea to open slowly, by little and little, into a full and clear light. Second, there is the method of relentless, systematic questioning. He never accepted anything as true just because someone important had said it. He interrogated reality. He broke down the biggest, most intimidating problems into small, manageable questions that he could actually answer through experiment and observation. He built his knowledge from the ground up, on a foundation of solid proof. He teaches us to be skeptical, to ask why, and to build our own understanding of the world piece by piece. And third, there is the virtue of immense patience and persistence. His willingness to set aside the problem of gravity for 20 years because he knew he couldn't solve it perfectly is a profound lesson. Genius isn't just about speed and brilliance. It's about knowing when to wait. It's about having the humility to admit you don't have the answer yet, and the tenacity to come back to the problem when the time is right, with the same fire and focus as before. Of course, you can't become Isaac Newton. You can't replicate the historical moment he lived in. And frankly, given his personality, you might not want to. He was a difficult, lonely, and often vengeful man. But you don't have to be Newton to use his tools. You can choose to carve out time for deep, uninterrupted thought. You can pick a problem in your own life, your work, or your studies, and attack it with a series of relentless questions. You can learn to be patient, to understand that the biggest breakthroughs often come not in a flash of insight, but after long periods of quiet, dedicated work. The apple never hit Newton on the head. That's just the story we tell ourselves, because it's easy. The truth is that the force of gravity was always there. The moon was always falling. He was just the first person who spent a lifetime asking why.